The selection of plate material is really dependent upon the quality of water you want to pass through the heat exchanger and the operating temperatures. There's been a tendency in the market to push more 304 into the market. Now 304 does not have any molybdenum content, so its resistance to chlorides is fairly low. You can use it on heating water, you can use it on pools, but your life cycle is actually short. Alfa Laval has always advocated 316, which has a much higher resistance to chlorides in most waters. So for steam, hot water, swimming pools, you can use 316 stainless steel. But again, it still has a limited life cycle, albeit much, much longer than 304. 304 can save you 10-15% in the investment price compared to 316. Then if you have a really corrosive environment, and for swimming pools we advocate using titanium, it will never corrode in those environments. So it's a one-off investment. 304 has to be seen as a consumable. It will corrode. In swimming pools, you're lucky to get 12 months. Cooling towers, 3 or 4 years, you throw the plate pack away and the end customer has to then reinvest in a new plate pack. So it's how you look at what is right, what the contractor is prepared to pay for initial installation, and who pays for the maintenance down the road. So Alfa Laval can advocate a material, but the contractor ends up making a financial decision on what he wants to buy. Most common is pressure spikes. They've hit the exchange with 20-30 bar pressure. They've popped out a gasket. It can be fixed relatively easily on site. They don't test the chloride level of the cooling towers. They're allowed to, in today's time, people are doing less and less blowdown of towers to save water, but they're concentrating up the chlorides. They need to talk to their chemical supply company and get that tested every few months. So high chlorides can corrode the plates, and that's where 304 will corrode much, much quicker than 316. Other issues is that come maintenance time, they're using non-trained contractors to clean the heat exchangers. There are some do's and don'ts on how you work or service a plate exchanger, and for a layman who's not trained for it, can easily damage the heat exchanger. We've seen this where people get screwdrivers and they try and prise the plates apart with a screwdriver, denting the plate or poking a hole in it. That can be easily done. Or they mistreat where it sits in the carrying bar, and if you damage the plate there, then it doesn't align properly. Yes, 304 is a better material for nitric acid. The problem is that nitric acid also chews gaskets. There are some chemicals or acids which are better in 304, but they're rare applications. If you got, say, a nice water bank. Some buildings years ago were building these huge ice bank systems for buildings, and then using the ice during the daytime for cooling the place. At close to sub-zero temperatures, your rate of corrosion decreases, and there's a graph where we can show you how free chlorides affect the corrosion of 304, and resistance increases as the temperature decreases, and you can get away with 304 in ice bank systems. Saying that, you still have to over months or years monitor the free chlorides in the water, and if it starts getting out of control, then change your water. But yeah, there are applications where 304 is quite suitable. In the norm though, it's going to give you a restricted life cycle. Free chlorides in water, they attack the stainless steel with increasing temperatures. So the rule of thumb is 316 plates are good for 300 odd ppm of free chloride up to about 50 degrees Celsius. It has 2% molybdenum, which gives the plate that chloride resistance. 304 does not have any molybdenum, and so at around 50 ppm and 50 degrees C, 304 will corrode. One has to be careful too. A lot of metallurgists will pull out charts that disagrees with us. They're talking about a non-stressed, non-pressed plate surface. All heat transfer plates are stressed because of the pressing process. Higher the stress, lower the resistance. And so a lot of boaties will come to us and say, oh, I got 304 railings on my yacht. Yeah, but it's not stressed. Okay, so yeah, so you really have low resistance to chlorides for 304, and that's why I say, I'll use the term restricted life cycle. You can buy it, it's cheaper, it'll last out through the warranty period if you're lucky, and then corrodes out.